So this is the last question in 4E, question 11. A ship K traveling at 25 kilometers an hour. So we have the speed of K, the magnitude of its velocity. We're asked to find the velocity of K. So the velocity of K, we call it xi plus y in the j direction. We have here h traveling east at 17 kilometers an hour. So velocity of h, 17 in the I direction and 0 in the j direction. And to an observer on h, so the velocity of k relative to h is k minus h, so x minus 17 in the I direction plus y minus 0, or just y in the j direction. And we have the speed of k being 25, so you can say the square root of my x squared plus y squared is equal to 25. We can say x squared plus y squared is equal to 25, which is 625. And the direction that it appears to be traveling in is northeast, so it's going in this direction where x is equal to y. So we can say that x minus 17 is equal to y. So we're going to have x squared plus x minus 17, which is y, to be squared, minus 625 is equal to 0. So we're going to get x squared plus x squared minus 17x twice, minus 34x, and 17 squared is 289, minus 625 is equal to 0. So we're going to get 2x squared minus 34x, and we'd have to take 289 away, 65, so take away 311 is 325 plus 11 is 336, minus 336 equals 0. So they all divide by 2, x squared minus 17x minus 168 equals 0. It looks like 24 by 7, just xx, 24 7s are 168, so that will work. 24 7, we want minus 17, so that has to be bigger. So x is equal to 24 or minus 7. And what does that give y be? Y is going to be equal to, when x is 24, we got y is equal to x minus 17. So y is equal to x minus 17, so y is 7. Or minus 7 minus 17 is minus 24. So we know that one of these will be correct. So we have 24i plus 7j, or minus 7i minus 24j for the velocity of, was it k? The velocity of k. Right, what's the velocity of k relative to h? It was northeast, wasn't it? Just double check, it was in a northeasterly direction, so it has to be positive. And we can see here that if we do both, check both anyway, we had x, what was it, x minus 17 and y, so the y isn't going to change. So x minus 17, 7i plus 7j, that's northeast, so that's definitely going to be the correct answer. Or, no, that was minus 7, the minus 7i minus 24j is going to give minus 24i minus 24j, which is in the opposite direction. So we discount that one, and we can say that this is the velocity of k. Okay, there's another part to this question. If k is 41 kilometers due west of h, k is 41 kilometers due west of h. We know it's going in this direction here. This, at a particular instant, find the shortest distance. Okay, shortest distance, we can say this perpendicular distance here between the two ships in subsequent motion to the nearest kilometer. So we need that angle inside the triangle based on the velocity, and it was 7i plus 7j, k relative to h. So that's, well, that's 7 over 7. That's going to give us 45, isn't it, in there? The inverse tan of 1. So we're looking for this over here. We're looking for x. So that's opposite and hypotenuse down the bottom. So the sine of 45 is equal to opposite over hypotenuse. So 41 sine 45 degrees is equal to x. And we put that into a calculator. 41 sine 45 to the nearest kilometer is going to give me 29 kilometers, being the shortest distance between them. And how long, for part 3, how long to the nearest minute are they within 30 kilometers of each other? Okay, well, let's do a new diagram for that. I can add to this diagram. So if they're within 30, that's 30. And that's 30. So we actually have the hypotenuse here being 30. And we have x being 29. So to find, we'll call this one y and this one y. To find y is going to be the square root of the hypotenuse squared minus the straight side that we have squared, which is 29. So y is going to give me 7.68. So 2y is going to give me 14 and 1.36, 15.36 kilometers. And then we need, so we're looking for how long, so we need the speed that they're going. We have distance, we need speed to get time. So the magnitude of the velocity, the square root of 7 squared plus 7 squared is going to give me the square root of 49 squared and 98, which is 9.9. So we divide 15.36 by 9.9. We're going to get the time. That's going to be 1.55 hours. And 0.55 by 60 is 33. So that's 1 hour, 33 minutes. This is how long they're in contact or within 30k of each other. So that's the last question in this section before we go on to the T method, the last section of this topic.